Good day everyone, welcome to term 2 of Corona Maths, and we put it in here. Okay, we'll be looking at just let me pause it for 1 second. Okie dokie, sorry about those little technical issues. Okay, we're going to be looking at a mixture of what we started last term, which is trig, compound, double, and special angles. Okay, and we're going to be working from Mind-Born Maths, exercise 4.5, page 141, A1, 3, 6, and 9, C, D, F, and 1 is what we're going to do. You should also have your information sheets with you. And in your information sheets, we're going to be using the double angle formula, which is sine 2 theta is 2 sine theta cos theta. You're going to be able to work with those in both directions. And then we're going to use the fact that cos 2 theta is 2 cos squared theta minus 1, or it can be written as 1 minus 2 sine squared of half of whatever that angle is, or it's going to be cos squared half of that angle, sine squared half of that angle. So in other words, cos 40 could be written as cos squared 20 degrees minus sine squared 20 degrees. Cos 80 could be written as 1 minus 2 sine squared 40. Cos 100, 2 cos squared 50 minus 1. Or for the whole exercise, I want you to try to do it without a calculator. Okay, we would be able to pick up if you use calculators. It's also good practice for NBTs. And what I use for special angles, you can use your triangles if you want. I generally work with a circle where we've got a radius of 2. This is just a quarter of the circle in quadrant 1. Okay, and if we work with a circle with a radius of 2 here at this point over here, we're going to look at those points at 30, 45, and 60. Those are your special angles. And at 30 degrees, the way I remember it is that your x-coordinates are getting smaller by 1 root each time. So that'll be 2, which is root 4. At 30, the x-coordinate will be 1 root less, which is root 3. Of course, that's nonsense to actually talk with that, but it works. That'll be root 2. That'll be root 1, which is 1. And at 90, your x-coordinate is 0. Okay? And then your y-coordinate at 0 degrees is 0. And it gets bigger by 1 root each time. So here it's root 1, which is 1. Over here it's root 2. And over here it's root 3. So we're going to need that fish. And here it's root 4, which is 2. So there's your special angles diagram. You should have your formula sheet in front of you. Okay. We also need to know your cast diagram. All students talk crap. Okay. And we're going to be using that as well. So the first question says, evaluate without a calculator sine 40, cos 40, sine 100. Okay, so give that a go. None of them are special angles yet. My suggestion, your first step you're always going to do in these kind of questions is get all angles to be acute angles. Okay. So what's the only angle which is not acute? Maxine? Yes, that's right. It's 100 degrees. Well done. That's an obtuse angle. So you're going to use reduction formula and go write that as express that as an acute angle. And the way you're going to do it, you're going to say where's 100 degrees? 100 is in quadrant 2, so you can write it as 180 minus. Okay. So we're just going to leave that as sine 40 cos 40, okay, sine 100 becomes sine 180 minus 80 degrees. All is done is I've rewritten 100 as 100 minus 80. So 180 minus 80. And Saka, what quadrant you in? Good, you're in quadrant 2. What happens there? Sine stays positive. So this is going to have be sine 40 cos 40 all over sine 80. Right. Hark, you say, those are not special angles. Indeed they are not, but there is a relationship between 40 and 80 in that 80 is double 40. So there are two ways we could proceed from here. The one is we could say, well, we know we're going to use this formula here. Okay, that sine 2 theta is equal to 2 sine theta cos theta. Okay, So if I wanted to change the numerator and express that in terms of 80 degrees, in other words, I want to isolate sine theta, cos theta, then you could divide by 2 and you could have a half, divide both sides of the equation by 2, and this is quite useful to use sometimes. A half sine 2 theta is the same thing as sine theta, cos theta. So what's that telling you? Well, sine 40, cos 40 would be equal to a half sine of 2 times 40. Okay, so sine 40, cos 40, so it's quite useful to be able to go from there to there. If you've got sine and cos of the same angle together, okay, it'll be a half sine double whatever that angle is. So this, if I use this method over here, it's going to become a half sine 2 times 40, half sine 2 times 40, sorry about the mess, all over sine 80, which gives you can skip out steps, a half sine 80 over sine 80, which is equal to a half. Alright? Okay, so you could change, once you get to this stage, you have to get to this stage, but once you get to that stage, you could change the numerator. But if you wanted to, you could also go change the denominator. Okay, in other words, you could make sine 80 a function of 40. And to do that, you're going to use the formula directly, in that sine 2 times an angle is 2 sine half the angle cos half the angle. Okay? So in other words, sine of 2 times 40, in other words sine 80, okay, so we'd leave the numerator, we're going to change the denominator, so I'm going to have sine 40, keep the numerator the same, cos 40, and sine 80, sine of 2 times an angle, in other words sine of 80 is the same thing as 2 sine 40 cos 40. So I'm just going to change sine 80 into 2 sine 40 cos 40, which is equal to a half. So either way, okay, so what are my steps? First, get them to an acute, anything which is not acute, like 100, get it to an acute angle. Okay, get all angles to acute angles, and you're generally using reduction formula. Okay, so get all your angles to acute angles, that's what we did first. Then once there's a relationship where the one angle is half the other, you can pick which one you want to change. Okay, so you could change the sine 80, okay, which is what we did over here. We changed that to 2 sine 40 cos 40, or we can use this fact, which is quite useful, that sine of an angle, cos of the same angle is half sine double that angle. Either way, you end up with an answer of a half, and that is A1 done. Okay, Katja, if you are still healthy and well, okay, Katja's going to do this sum for us. Okay, and so Katja, what do you notice? And yes, good girl, you notice that those are both not acute angles, so you've got to get them to acute angles. So you say to yourself, self, where's 105? It's in that quadrant. Okay, so I can write that as 180 minus something. So we're going to have 2 sine 180 minus 75. 180 minus 75 is 105. All I've done is change 105 into 180 minus 75. Cos 255. Well, 255 is in this quadrant. So what did you say? Yes, Katja, that's right. You're going to write this as cos, is that a bit of a cos? 180. Remember, don't ever work with 270 plus or minus. If it's in this quadrant, work with 180 plus. That one 180 minus. This one 360 minus. So it's going to be 180 plus 75 degrees. Just remember, you're never going to look at these sums and think, oh, I know exactly how I'm going to do that. You just follow a process. First process, okay, get everything to be acute angles. So sine 180 minus 75, you've got to use reduction formula here. You're in which quadrant? Quadrant 2. What happens to sine? It stays positive. So it's going to be 2 sine 180 minus 75 reduces to sine 75. Cos 180 plus 75. I'm in this quadrant over here. What happens to cos in the third quadrant? Good, it becomes negative. So that's negative cos 75. And if we neaten that up, you should hopefully see a pattern now. I've got negative 2 sine 75 cos 75. And I always think this section is pretty fun. What purpose does it serve? I have absolutely no idea. Apart from that, it's really good at kind of teaching you to use logic and formulas. So, what pattern am I looking for? 2 sine 75 cos 75. Well, we've got that pattern over there. 2 sine of an angle cos of an angle is sine of double whatever that angle is. So you're going to have negative 2, negative, then the 2 sine 75 cos 75 is sine of 2 times 75. You can skip out steps once you're comfortable with things, which is negative sine 150 degrees. And that should make you very happy. Why? Because you can get that to a special angle. What are your special angles? 30, 45, and 60 degrees. How can I get 150 to a special angle? Well, where's 150 in quadrant 2? Okay, calculating so well. So you're going to write that 180 minus 30 degrees, which is sine of 180 minus stays positive. So I keep that negative, and that doesn't change. So that's just negative sine 30. And negative sine 30. What's the definition of sine? Shade your rear, remember, because x rays tan your exterior. And you can have a picture of anybody you'd like to imagine shading their rear, okay, because x rays are tanning their exterior. So sine is the relationship of the y coordinate over the radius, okay, and the y coordinate at 30 degrees is going to be equal to negative 1, and the radius is always 2. So your answer, unless I've made a deliberate mistake, is negative a half. So what do? Anything which is not acute, get to acute. Okay, just use your reduction formula by using your cast diagram, and then look for your patterns with your double angle formula. Okay, and you go all the way from there. Quite a lot of fun. Get that done. Okay, right. Let's have Roger. You know who you are. Okay. Yes, Roger's girl. Okay, cos 40 plus 2 sine squared 200. Okay, let's give this a go. Right, so when you look at this, the first thing you want to do with any square, I always think, is rewrite this as 2 sine of 200 all square. Because that means that everything's going to end up being, that reduction is going to end up being positive, and you can use that to save quite a bit of time. We'll go through the steps though in this case. So this is, first thing we're going to do, find the angle that's not acute, which in this case is 200. Okay, and then we're going to say, right, I've got cos 40, we'll leave that. Remember, plus 2 sine, well, where's 200? 200 is in this over here in quadrant 3, so you can write it as 180 plus 20. So it's 2 sine 180. As I say, you can skip out steps once you're comfortable with all of this. 180 plus 20. Okay, and then we'll keep cos 40 there for now. So cos 40 plus 2 sine 180 plus 20. I mean, this quadrant over here, it becomes negative sine 20. Okay, but it's squared, which means I'm going to end up with cos 40 plus 2 sine squared 20, because when I square the negative it becomes positive. That's why that step's so important, I think, in putting the square over there. You could quite happily, you wouldn't lose any marks if you went from there straight to there. If you just went in your head, sine 180 plus 20 is negative sine, do all of that but in your head and go straight to there, that's absolutely fine. Just be careful of careless mistakes. Right, so now you've got a relationship where the one angle is double the other angle, which is good news because we can use double angle formula. So I could go change sine squared 20 by isolating sine squared. It means you're going to have cos 2 theta plus 1 divided by negative 2. It's a bit of a mission. It's easier probably to get express cos 40 in terms of 20 degrees. Okay, and we may as well stick to sine. So cos of 40, I could write it as 2 cos squared 20 minus 1. But probably the easiest in this case, because I've got a sine over there, is to write cos 40 as 1 minus 2 sine squared 20. Remember 2 theta, that's half of that. So cos 40 I'm going to be using the fact that cos 2 theta is 1 minus 2 sine squared theta, so cos 40 is 1 minus 2 sine squared 20. So that is just that. Okay, make sure you're comfortable with that. Plus 2 sine squared 20. Those are like terms, you add them up. Negative 2x plus 2x, you've got no x, and you're left with an answer of 1. Isn't that lovely? Roger, well done, congratulations. You have served your numerous countries incredibly well, and your dad would be proud. Right, I'm quitting. Okay, the question here is evaluate this without a calculator. And double angles should scream at you because double 15 is 30 and double 22,5 is 45, and 30 and 45 are special angles. So if you want to put the 15s together, and that's going to be, remember, always try to do these questions first before you go through the answers with me here. Minus sine squared 15 degrees. I'm just rewriting it. And now it's about pattern recognition. So the first pattern we should look for is this one over here. We've got cos squared of an angle minus sine squared of an angle. Where does that come up? Well, over here. Cos squared of an angle minus sine squared of an angle is cos of 2 times whatever that angle was. So this bit over here will become cos of, what, Karen? Good, 2 times 15 degrees. Right? And then another pattern we've got here, sine 22 cos 22,5. Well, that's that over here. And sine theta cos theta, remember, is the same thing as as a half sine 2 theta. Sine theta cos theta is equal to a half sine 2 theta. So sine of an angle cos of an angle is equal to a half, so it's going to be plus a half, okay, sine of 2 times that angle, and that's kind of the hard part of the sum done. We're picking up those patterns. That's that one over there, that's that one over there. Right, go finish that off. You have to use your special angles diagram. Give it a go. Right, so we end up with cos 30 plus a half sine 45. Karen, what's the definition of cos? Yes, x over r. Okay, and at 30 degrees, what's your x value? Good, it's √3, and your radius is 2. Well done. Plus a half sine 45 is going to be equal to, at 40 sine, shade your rear. The y value at 45 is √2 over 2. And believe it or not, you can do that without a calculator, incredibly. So it's √3 over 2 plus √2 over 4. Okay, and you can get a common denominator of 4. So this will become 2 √3 plus √2 over 4. Am I right? I think so. Times the bottom by 2, times the top by 2, and voila, which is, fortunately, Karen made a bit of a mistake in adding those without a calculator, but that was okay. She had a tough time in grade 1. Okay, right, Mavea has volunteered to do the sum over here, and because she thinks it's pretty innocent, but actually, this is quite a sneaky question, okay, but nothing that Mavea can't handle. So, the first step, or top thing, what she said we must do, and I want you to go try, is use reduction formula to get those to special angles. Always do that as your first step. So 110 degrees is in this quadrant, so you can write it as 180 minus, so it's going to become sine 180 minus 70 degrees. Okay, just rewritten that. Cos of 70 is acute, so we're going to leave it like that. And tan of 190 is going to be tan 180 plus 10 degrees. Okay, 190 is over here. Right, so now I go use go use your reduction formula. And Merve, what's sine 180 minus 70? Good, sine 70. Okay, sine positive plus cos 70. And tan 180 plus 10, what did you say? Negative tan 10? No, Merve, you're being a dumbass. What's tan of 180 plus 10? It's in quadrant 3. 180 plus tan is positive, so it's going to be positive tan 10 degrees. Right. So you look at that and you think, oh my goodness. Okay, and you should think, oh my goodness, because there's actually not that much we can do here. If it was 80 and 10, that would be fairly easy probably, because we could play around with that. So at this stage, we're kind of stuck. There's no pattern, okay, that we can see over there. So there's really only one thing I can think of, and that is to work with that tan 10. Okay, so go get it to sine and cos. How can I write tan? Remember, tan of an angle is the same thing as sine theta over cos of that angle. So in other words, we're going to have sine 70 plus cos 70. So what's that going to become? Exactly, Merve. Sine 10, you have redeemed yourself, over cos 10. Right? Which means, times the top and the bottom together, we've got sine 70 over 1, I often do that with fractions, plus cos 70 sine 10, I times the top and I times the bottom, all over cos 10. Again, at this point, okay, you're going to think, I'm going nowhere, but you actually, patience, dear people. Okay, right, so how do you add fractions together, Boati? Okay, you get a common denominator, and my common denominator is cos of 10 degrees. So whatever you do to the bottom, no matter how disgusting, you do the same thing to the top. Times the bottom by cos 10, I times the top by cos 10, and I get sine 70 cos 10 plus cos 70 sine 10. Okay. Now this, there's a pattern here. Sine of an angle, cos of another angle, cos of that same angle, sine of that same angle. Okay, that says cos 70 here. And what pattern is that? Go look at your formula sheet. If you look on your formula sheet, you'll see that you've got, if you had sine A, look for this on your formula sheet. Sine A cos B, that's the pattern, sine A cos B plus cos the same angle, so let's call it cos A sine B. Okay? That angle and that angle is the same. So that's a pattern. That pattern is the same thing as that pattern. Go have a look at your information sheet. Okay, and find out where you see that. Okay, and when you see that pattern, you see that that is equal to sine of the one angle plus the other angle. So this over here, sine 70 cos 10 plus cos 70 sine 10, I can write as, I'm going to go over here, sine the one angle plus the other angle, 70 plus 10. I use this formula over here to do that. Okay, so it becomes sine 70 plus 10. That pattern over there becomes that, all over cos 10, which is sine 80 over cos 10. Now remember, sine of 90 minus an angle is the same thing as cos of an angle, and vice versa. So in other words, sine 20 is the same thing as cos 70. If they're complementary, you can swap them around. Cos 30, sine 60, cos 5, sine 85 are all equivalent. So you can either go make sine 80 cos 10, or you can make cos 10 sine 80. Okay, so let's get them both to cos. So sine 80 is the same thing as cos 10 over cos 10. So I get an answer of 1. Okay. Merve, Boati, splendid job. High five yourselves. Everybody get that down. It's quite a sneaky question. Again, what the steps? Get rid of your angles bigger than 90 degrees. Okay. And don't panic in these questions. Okay. Do what you can. and have fun. Right, we're going to have Tiasha and Bianca doing the next one. The question says, express cos 3a, which question was it? Question D. Express cos 3a in terms of cos a. So you wouldn't answer, we've only got coses, and the angles are only a. You can have cos squared a, you can have cos cubed a, cos to the 4a, whatever, but you can only have cos, no sines or tans, and you can only have angle a. So, what we're going to do here, I know, it's confusing, but that's what you're going to do. You're going to write 3a as cos 2a plus a. Now you've got a compound angle formula. So I want you to apply, on your formula sheet, if you look, you've got cos a plus b is cos a cos b minus sin a sin b. Cos of an angle plus another angle is cos of the one angle, cos of the other angle minus sin of the same angle there, sin of the other angle. Go up, use this formula and apply it to that. Give it a go. Okay, so cos 2a plus a, what is that going to become, Tiasha? It is cos of 2a cos a, good, with cos it's the opposite sign, minus sin 2a sin a, right? So at the moment, the only thing that makes us happy is this cos a. The next problem I've got is it says express in terms of cos a, and there's cos 2a. So I've got to get rid of that cos 2a, and I've got to get rid of that sin 2a. Right. Now, you've got a choice for cos 2 theta. Okay, three things, but the question said get in terms of cos a. So you're going to use that formula over there. Sin 2a is only one choice. Right, go get rid of your double angles. Try that. Okay, so Bianca, what you're going to get, not copy this time, unlucky. So cos 2a, I don't know how you're coping. Cos 2a is 2 cos squared without your instant delivery every day. Cos 2a is 2 cos squared a minus 1. Okay, times cos. So I've just changed cos 2a into that. Okay, and there's that cos a. And I've got the minus sign. And sin 2a, yes, that's quite right, is 2 sin a cos a. Best of you people, always top of the game. Okay, sin a. Right. So, let's go simplify that a bit. Go distribute that. And you're going to get 2 cos cubed a minus cos a, and over here you're going to get sin a times sin a is sin squared a, because I can't change sin a into cos a, but sin squared a should make you happier. So I've just said sin a times sin a is sin squared a. Right, that's just that whole step over there, multiplied out. Right, so this is cos and a, this is cos and a, I don't have to worry about that. There's cos a, that's great. The only problem I've got is sin squared a. So how can I write sin squared a in terms of cos a? Okay, well we know that sin squared a plus cos squared a is equal to 1. Okay, so sin squared a is equal to 1 minus cos squared a. So go replace sin squared a with 1 minus cos squared a, simplify, add like terms, and you're done. Give it a go. So I've got 2 cos cubed a minus cos a. So Tiasha minus 2. I'm going to put the multiplication, so it's commutative, so I can put that in front. So I get minus 2 cos a, and then sin squared a. What has it become? Good. 1 minus cos squared a. So I end up with 2 cos cubed a minus cos a minus 2 cos a, I times this out, plus 2 cos squared a, add like terms, done something wrong, how about that? Cos a times that is cos cubed. Okay, negative 2 cos a times negative cos squared a is positive 2 cos cubed a, right, and add like terms, and I get 4 cos cubed a minus 3 cos a, and that is exactly what Tiasha and Bianca got. Nice sum. Okay, you've got to change the 3a into a, okay, etc. Okay, using a combination of formulas. one more sum coming up. Okay, last sum, and we're going to get sharers to it, and it's quite a nice sum. The question is solve for p, such that p lies between 0 and 90 degrees, so we're going to have a trig equation. So solve, it's question F number 1. Solve for p lies between, such that p is an angle between 0 and 90, and it's much more fun if we do it without a calculator. Okay, right, and this is a kind of sum to put hair on your chests, which I know the sharers are aiming for. Okay, so sharers, up to you. Let's see if you're man enough to do this. Right, and the first thing you correctly said, okay, is you've got sine of negative angle. Now remember, negative angles behave like they're in quadrant 4. Okay, they're not in quadrant 4. Just think of it, it's just a way of remembering it. Okay, so sine of a negative angle is the same thing as sine of negative angle is negative sine of the positive angle. So sine of negative 242 is negative sine of 242. So far so good. Right. Then cos of 90 minus p. Okay, 90 minus in quadrant 1, 90 must end up alarm bells, reduction formula. Cos changes to sine. So it'll be 2 sine p using reduction formula. That's that bit over there. Okay. And cos of a negative angle, well, cos of a negative angles, we can treat them as if they're in quadrant 4, even if they're not, is the same thing, cos stays positive. So, sharer, good, that becomes cos of 329 degrees. Right, so now, this is getting a bit interesting, so you have a little heart attack now, and you look at that thing and think, how the hell on earth am I going to do that without a calculator? But luckily, the sharers know, because they listened, and they recognize that if something is not acute, get it to acute. So, where's 242 degrees? Well, 242 is between 180 and 270, so it's in that quadrant, so you're going to write 242 as 180 plus something, and 329 is between 270 and 360, so 329 is over here, 242 is there, so 242, go right there, it's 180 plus something, 329, go right there, it's 360 minus something. Okay, off you go. And then go use your reduction formula. Why? Because you've got to get everything to acute angles. Give that a try. So, negative sine 242 is negative sine 242 is 180 plus 62. Hopefully I'm right. Okay, 242 is going to be equal to 2 sine p times cos 329 is going to be 360 minus 31. Okay. Right, go to your reduction formula. Okay. Miss M, what's that going to be? Okay, it's going to be negative sine 180 plus 62. Okay, and we end up with that sign's going to become negative. So it'll be negative sine 62. Sine 180 plus 62 in quadrant 3, sine becomes negative, is equal to 2 sine p. As I said, this is a grown-up sum. Put it in your chest. Cos 360 minus 31 is going to be, cos stays positive, good. So it's going to be just cos 31. So if we simplify that, now we've got sine 62 is equal to 2 sine p cos 31. And what was the question? You've probably forgotten. So solve for p. So you've got to get sine p on its own. Okay? So you should be starting to get a bit excited. Okay? Because 31 is half of 62. Double angle formula should come into play. So I get sine of 62 divided by 2 cos 31. Why am I doing that? Because I'm asked to solve for p, so I want to isolate the trig function. Right, so now we're going to have, I'm going to go up here, sine 62, okay, well, sine, that's double that. So sine of 2 times an angle is 2 sine angle, cos of an angle. Okay, so sine of 62 I can write as good 2 Sarah dry lasagna. Eating dry lasagna, shame. So, yes, what did you get? Let's see how that dry lasagna works on the brain. 2 sine 31 cos 31. What I've done is I've said sine of 2 times an angle is 2 sine half the angle cos of half the angle. In other words, I've used that formula over there. So sine 62 is 2 sine 31 cos 31, okay, over 2 cos 31. Oh, I'm making a bit of a mess. And that is all equal to sine p. And if I go down here, 2 cos 31 and 2 cos 31 cancels out. So I'm left with sine 31 is equal to sine p. Right, so you've got sine 31 is equal to sine p. Go solve for sine. Okay? Well, normally you'd go, they only want the answer between 0 and 90 degrees. So normally you're going to go, if you've got sine of an angle equal to sine of another angle, you'd say 31 is equal to p. So let's do the other way around. P is equal to 31 plus k 360. Or you'd say P is equal to 180 minus 31 plus k 360, k, which is P is equal to 1, what's that going to be? 180 minus 30 is 150, 149, I think. Yeah. 80 minus 30 is 150. I think so. It doesn't really matter actually. Right, because those are your two general solutions, but they only want the answers between 0 and 90. So your solution is simply P is equal to 31 degrees, which amazingly, Sarah M and Sarah Matsot's, in other words, the sharers got correct. So P is equal to 31. You could have just put the answer from here straight away, said P is equal to 31. Okay, because if it's an acute angle, that's the only one that's going to satisfy that. And that has been correctly done, and no doubt hair will start sprouting on your chest anytime soon. So congratulations, very impressive. Okay, so all that's left to do, okay, is on your own, and when you get some time, Mind-Born Maths, exercise 4.5, page 141. Do the sums that we didn't do on the video today. So it's A, 2, 4, 5, 7, and 8, and B, E, and F, 2. Have fun, and may the force be with you.